turn the music up, I got my records on. I shut the world outside until the lights come on. Maybe the streets are alive, maybe the trees are gone. I feel my heart stop beating to my favorite song. And all the kids they dance, all the kids all night until Monday morning feels another life. I turn the music up, I'm on the other side, and heaven is inside. Turn the music up, I got my records on. From underneath the rug, I'll sing a rebel song. Don't wanna see another generation drop. I'd rather be a comma than a full stop. Maybe I'm in the black, maybe I'm on my knees, maybe I'm in the gap between the two trapezes. But my heart is beating and my pulse is starting. Cathedrals in my heart, a sweet song. What it's like, I swear you emerged beginning to tell me it's alright. A sweet song. Every sound is the same for me.
The objectives of my work are the knowledge of complex numbers and the application of complex numbers, and at the end the study of iterative fractals by Newton's equations. Complex numbers can have an algebraic and a trigonometric form. Let's start with the question. What is a real number whose square is equal to -1? Normally, the square root of a negative number doesn't exist, but it might exist as an imaginary unit that is pointed out by the symbol I, and it's equal to the square root of -1. So the algebraic form of complex numbers is z plus I, is z equal to I plus high b, where A is the real part and B is the imaginary part.
A fractal is a geometric figure in which an identical motif is repeated in a continuously reduced scale. This means that if you zoom the figure, you will get recurring form, and in each magnification it will reveal new details. The main properties of fractals are self-similarities. If details are observed at different scales, there is always a rough resemblance with the original fractal. And indefinite resolution, it is not possible to define clear and absolute boundaries of the wall. And fractional dimension, even if they may be represented in a 2 or 3 conventional space dimension, their size is not full, or better, what measures their degree of irregularity is a fractional number.
When Richard Taylor, professor of physics at the University of Eugene, saw blue pulse number 11 painted by Jackson Pollock, came natural to think of fractals. About this blue pulse number 11 was painted in 1952 and today is in National Gallery of Canberra in Australia. The computer-assisted analysis, noticed that Jackson Pollock created a dense web of fractals. This dense web of fractals can be seen also in Lavender Mist, another painting of 1950. Richard Taylor used the third method, or box counting method, in order to calculate this fractal dimension. Box counting, or Minkowski-Bulligan dimension, or Minkowski dimension, is a way of determining this fractal dimension. The formula that you can see explains us how can we calculate this dimension.
The modern fractal art is developed later to the Mandelbrot's theories. And two exponents of this artistic current are Fernando Garbellotto and Carrie Mitchell. Fernando Garbellotto got in contact with multiverse theory at the end of the 1980s, and these are the most important work that are called fractal nets, particular toys that were worked, painted, cut into stripes and then tangled. Carrie Mitchell thinks that the modern fractal art is a very particular art. In fact, it isn't for everybody.
Disease.